Hey guys, Buildzoid here, and today we're going to be taking a look at the Sapphire RX6950 XT Nitro Plus Pure PCB. The PCB pictures are from TechPowerUp's review of this card, so big thank you to them for providing high-res PCB pictures, and there will be a link to their review of the card down in the description below, so if you want more information about the card, you should go check that out. Anyway, so this is one of the... So basically every time a new GPU gets launched, the first thing I do is I go look at the PCBs. And this PCB got my attention pretty quickly because of this black stuff right here. See, this black stuff is known as underfill, or at least I'm assuming this is underfill because I can't really think of anything else that it could be, especially since they're only using it on some of the memory chips and not on all of them. But anyway, so assuming this is underfill, Sapphire is underfilling these four memory chips down along the PCIe slot edge of the card. And the reason this got my attention is because the reason you use underfill on BGA packages like memory chips or chipsets or, well, really any BGA package is because underfill is used to improve the mechanical and thermal reliability of BGA, packages. And so I find this really interesting because you just don't see any other manufacturers doing this. And it's pretty obvious, or at least... So, well, this one I'm a bit confused about. But these three, I think it's pretty clear that the reason why Sapphire is putting underfill under these three memory chips is because they're right next to the PCIe slot. And modern high-end GPUs have very heavy heat sinks. Which means that when you have the GPU installed in a motherboard, this part of the PCB is basically fixed in place, but the rest of the card is getting pulled down on by gravity because of the heatsink. And basically what that does is you get, like, the PCB starts bending in this sort of area, right? Which would basically, like, the potential issue with that is it's gonna be bending the memory chips, which is bad for the reliability of the BGA of the memory chips. So Sapphire is evidently counteracting that by underfilling the memory chips by the PCIe slot. So that is cool to see. I don't know how much of a effect on reliability this actually has, since Sapphire is basically the only manufacturer I'm aware of that's doing this with their 6000 series GPUs. That I actually went back and checked, and they did this even on the 6800 XT. So this is not like this is not a new thing. Like, they've been doing this for a while, but I find it very surprising that they're the only manufacturer that is using underfill on their high-end Radeon GPUs for the memory chips by the PCIe slot. Now, this one's not really by the PCIe slot, which is why I'm kind of confused about that one. But yeah, so that is a interesting sort of, I guess, reliability improvement that Sapphire is doing to their cards. It would be really cool to know how much of an effect this actually has. But yeah, that's sort of that's what got my attention about this card, is just like, oh, they're underfilling the memory chips. That's not something you see very often, even though it makes a lot of sense, because these memory chips really do struggle with the fact that the PCB tends to bend in this area. So yeah. Anyway, other than that, we've also got fuses on the card. So we've got an 8 amp fuse on the PCIe slot. We've got a 10 amp fuse on the 6-pin power connector over here. We've got two 10 amp fuses for each of the 8-pin power connectors. And the fuses, so these don't really improve the reliability of the card, they improve the repairability of the card. Basically, if you have a catastrophic power delivery failure on a GPU, or really anything, it's just that you don't see fuses on motherboards. That's just not a thing at all. But, on some GPUs you do get fuses, like Sapphire cards. MSI also likes to use fuses. Gigabyte occasionally uses fuses. EVGA uses fuses. A lot of other manufacturers don't. But basically, if the card suffers a catastrophic power delivery failure, which on a card like this really shouldn't happen, but, you sometimes get dodgy power stages produced, or you just get very unlucky kind of scenario. So, catastrophic power delivery failure. The fuse basically drastically limits the amount of damage that a failing power delivery component can cause. One, because it might, if you have a bad if your power supply has a really slow protection mechanism, that fuse would actually cut off the power to the failing component faster than your PSU, which limits how much energy goes into the short circuit. Consequently, it limits how hot the short circuit can get, meaning it's less likely to burn a hole into the PCB. It's less likely also to send high voltage out the output of the VRM, which is another concern with failing power delivery components. And then also, if you have a PCB with no fuses, after the after the component has failed, a lot of people will just try to power cycle the card because it's like, oh, the computer doesn't work. I don't know why it doesn't work. Let's try turn it on. And every time you power cycle the system with a failed power delivery component on a GPU, you are causing more damage. Now, if you have a fuse and the fuse has blown, every time you power cycle the system, nothing will happen because the fuse is preventing any more power being applied to the failed part of the PCB. So the fuses significantly improve the repairability of a GPU, because when you have a power delivery failure, it's much less likely to put a hole in the card or do something like kill all of the memory chips and or core. So yeah, that's another sort of, it's not a reliability upgrade, but it's a cool little repairability upgrade that Sapphire is doing to this card. And admittedly, this only, is useful once the card is outside the warranty period, because while the card is in the warranty period, regardless of what kind of damage the card has sustained, that's the manufacturer's problem. But at least if you plan to keep your card for a long time, the fuses are just a nice addition in terms of, making the card less likely to be unrepairable if it fails. So yeah, we have a lot of sort of I guess you could consider reliability upgrades on the card. Other than that, we also have dual BIOS on the card, so there's a dual BIOS switch up there. And that means if you want to mess around with flashing different BIOSes, you can do that. And also you just have two BIOS chips on the card. So I've never experienced a BIOS corruption on a GPU myself. Every time I've had a BIOS issue with a card, it's because I flashed a bad BIOS to it, not because the BIOS just broke itself. That's not really a thing in my experience. But if that ever did happen, you do have a BIOS switch, so that you're not going to be, that's going to make life a lot easier. So now then, let's talk about the power delivery. And power delivery wise, we're basically looking at the same VRM configuration as what you would get on a 6900 XT Toxic, except I think with different power stages. So we have a two-phase SoC VRM over here. Then this right here is a whole bunch of V-Core. And then on the other side of the card, we've got V-Core over here, just the one phase hanging out all on its own, chilling on the top edge of the card. The reason they've done this is because Sapphire basically decided to really sort of stick to the reference PC VRM layout. So below that, we have the memory VRM, which is this right here, two phases. So we're just going to put mem. Then under that, we have the memory controller power rail. So I'm going to just put IMC on that for integrated memory controller, because GPUs have the memory controller integrated into them. And then below that, we have more vCore. So yeah, we've got kind of a scattered vCore VRM layout because, I mean, there's that one phase just chilling on the top edge of the PCB. And the whole reason they did this, as far as I can tell, is because, well, I think they shifted the card up a bit. Because normally you would only have 6 phases in this part of the card, whereas here we have 7, right? This is 7 phases. A reference card would only have 6. But on a reference card, you'd have your 6 phases, then you'd have your memory controller, memory, and then you'd have nothing. And evidently Sapphire was like, no, we put vCore up there. Yeah, that's a bit weird, because you would have thought maybe they would have, I don't know, they could have shoved it sideways over here. It would look really wacky to just have one phase at a completely different angle from the rest of it. But yeah. Or I think Power Color did, actually no, I think Power Color just put six phases on the same side. Anyway, so that's just kind of a interesting layout choice by Sapphire, that they decided this is the simplest way to set this up. Anyway, in terms of the VRM controllers, we have the same stuff you would expect to see on any 6900 XT, except on a 6950 XT. So this chip over here is an Infineon XDP E132G5D. the D, as far as I can tell, is like an AMD specific GPU variant. And here it is running in a 13 plus 2 phase configuration. So that's your V-core, and then plus 2 is the SoC. And then above that, we have an IR35217, which is just ridiculous overkill. This is an like 6 plus 2 phase controller that was originally used on the Vega GPUs for V-core and HBM power, if I remember correctly. Anyway, 35217, also from Infineon, because International Rectifier now belongs to Infineon, running in 2 plus 1 phase mode. And that's why I said it's like super overkill, because it's just like, why, like you have a 6 plus 2 phase controller and you only run it in 2 plus 1 phase mode. But on a card that costs over $1,000, you know, spending $1 or $2 more on the controller really doesn't make that much of a difference. So it kind of makes sense that they just decided to go with this instead of something else. But yeah, so that runs as 2 plus 1, and that's your memory plus IMC power delivery. And I've just realized that my like capitalization of these terms is just well, no, because memory isn't an abbreviation; it's part of the word memory. So actually, that does make sense. All right. No, whatever. I'm not good with words. Let's just leave that alone. So that's how the VRM is controlled. Which incidentally, both of these are like high-end digital multi-phase voltage controllers from Infineon. Like this is, whoops, this right here is basically the best thing Infineon has for GPUs, as far as I know, and this was the best thing Infineon used to have for AMD GPUs, like a year before this chip came out, or 2 years before that chip came out. So, yeah. Anyway, for the actual power stages, we're looking at a bunch of TDA 21472s. These are 70 amp smart power stages, so they have built-in like current monitoring, temperature monitoring, as well as a bunch of safety features like overcurrent protection, over temperature protection. I want to say short circuit protection, but I can't remember, and it doesn't matter. Basically, these are called smart power stages because they integrate a whole bunch of functionality that would otherwise have to be provided by external circuitry or just not present on some cards. Like there's a lot of cards where you just don't have, you know, over temperature protection because just kind of hope that the VRM never overheats. Admittedly, on a card like this, VRM really shouldn't be in a situation where it overheats, but even then. So yeah, 70 amp smart power stages. These are very efficient, and as a result, the core power delivery, like the power delivery capabilities of this VRM to the core, end up being that 350 amps output. You're going to be looking at about 29 watts of heat, roughly coming off of just the power stages. This doesn't include the power losses in the inductors or the power plane. And the power plane power losses are the whole reason why high-end modern GPUs have this sort of like scattered power delivery setup where you have V-core on both sides of the core, because instead of having one power plane that just sort of looks like this, you can have two power planes that look something like this. And effectively, you get like extra cross-section to reduce the resistance of the power plane, reducing the power losses in the power plane, improving the efficiency. Also, it would reduce the inductance of the power plane. So you just get better power delivery by having this sort of double-sided, like, well, multi-sided VRM layout to deliver power to the GPU core. And now for comparison to the reference card uses a 10-phase VRM using the exact same 70 amp power stages. The reference card would be doing 350 amps while producing about 33 watts of heat. So it's not a huge efficiency difference between the reference card and the Nitro Plus, but also consider that the Nitro has 3 more power stages across which that heat output is spread, so the thermal density of this VRM is quite a bit lower than what you get on the reference card, even if the efficiency itself isn't that different, as in the heat output isn't that different. And then for a 500 amps output, which is like, so this would be like air-cooled, water-cooled, overclocking territory. You can probably go a bit above that on water cooling. But then for like LN2 overclocking, 500 amps output, this VRM would probably produce, well, the power stages in this VRM will produce around 49 watts of heat. And that is actually a like 11 watt improvement over the reference card. The reference card would be producing about 60 watts of heat. So yeah, this should like, as far as the power delivery is concerned, this is very, very capable. If you wanted to take one of these on LN2, I really see no reason why you couldn't. Well, one of the things you might run into is that you might blow the fuses. Because you do only get, with the fuses as they are configured, you only get 240 watts per 8-pin power connector, and especially the 6-pin power connector, you only get 120 watts on it. So depending on how exactly the phases are assigned, during some very intense benchmark scene, you might end up actually like popping, like one of the fuses or all of them. I'd imagine it would probably go something like you pop one fuse, so you replace it, then you run the benchmark again and you blow a different fuse, so you get rid of that one too. And you'd probably end up with no fuses by the end of the session. But yeah, that's kind of the only real issue that you could have with trying to run this card on LN2, because the VRM itself is very, very capable. And so the really the only limiting factor would be maybe the fuses. So yeah, just a very powerful V-Core VRM on this. The SoC VRM is two phases of the same TDA21472s, and the SoC VRM really doesn't need to supply that much current to the core, so yeah, we're not going to go into detail on that one. The memory controller and the memory power is also just more 70 amp smart power stages, which is massive overkill, because the memory really doesn't pull that much current. Yeah, that's sort of the power delivery capabilities of the card, and it's very, very good. It's not the most powerful VRM that you can get on a 6900 XT, but the thing is, like, this really shouldn't struggle with any kind of overclocking scenario that you could throw at this card, as is. So basically 6950 XT PCBs come in like good to extremely overkill build quality setups. And yeah, so power delivery wise, this is definitely like, good would be like the reference card. This is already quite a bit better than the reference card. So yeah, like this is a very, very solid power delivery system for a 6950 XT. And then in terms of output filtering, I do appreciate that Sapphire actually went and populated all of the output filter, all of the bulk capacitor pads for the important power rails, like the memory and the SoC, and V-Core, right? So we have all of the V-Core capacitors, and well, basically, it's easier to point out the capacitors they didn't populate. Like this one over here, if I'm not mistaken, is for the 1.8 volt rail. The 1.8 volt rail is a supporting power rail for the memory chips, and I think it powers the BIOS chips, and basically it doesn't matter, which is why I don't care that they decided to cost optimize away this one capacitor, because it's not going to affect overclocking. Same goes for this capacitor down here. This one, off the top of my head, I want to say is for the 0.75 volts rail. Same thing, that rail is necessary for the GPU to function, but it has no impact on overclocking whatsoever, so it doesn't need to have spectacular filtering, because it's just kind of there to make the card function, and it functions just fine with one bulk capacitor. It really doesn't need two. But on the power rails like the SoC and of course V-Core and memory controller, those are fully populated with 470 microfarad aluminum polymers. I want to say, and these are also 2.5 volt, which is kind of interesting that they went with 2.5 volt parts, not just 2 volt parts, because the 2 volt parts would be slightly cheaper. Not that there's any the thing is, there wouldn't be a downside to using 2 volt parts, because you wouldn't be running a 6900 XT above 2 volts anyway in any scenario. So yeah, I'm kind of surprised that they're going with 2.5 volt rated caps, but that can actually slightly improve the lifespan of the capacitors if you have them slightly overrated for their... Well, the thing is, even a 2 volt capacitor, at stock settings, these cards run at like 1.2 volts. So a 2 volt capacitor is already very overrated for a 1.2 volt power rail. But yeah, it doesn't hurt. It's just kind of surprising that they decided to go that way. So yeah, the output filtering on this card is solid. However, the input filtering in typical 6900 fashion, because the funny thing is, a 6500 XT generally has more input filtering than a reference 6900 XT. So in typical 6900, like RX 6900 fashion, the input filtering is very light on the bulk capacitance, which means potentially your power, and also there's not a lot of inductance on the input, like the input filtering inductors are relatively low inductance. So potentially your power supply is going to be dealing with more switching noise than if you had a card with more bulk capacitance. Now, without oscilloscope measurements, it's hard to say how detrimental this actually is to the operation of the card, if at all. But yeah, it is I'm not a fan of the fact that 6950 XTs and 6900 XTs and 6800 XTs come with basically no 12 volt bulk capacitance, because we basically get you get these four capacitors over here, these two over here, this one over here, and then you get this one 150 microfarad tantalum over here. And the CAN capacitors, those are all just 180 microfarads each. So this is very little 12 volt bulk capacitance, which is typical for these cards, but I just, like, if you look at something like, say, an RTX 3080, that has one bulk capacitor per phase. Like, every single phase basically has its own bulk capacitor, and then you have like 6900, 6950 XTs like this, where you have, a 13 plus 2 phase, like main core power delivery system, or just like 13 phase V core, and there's half as many bulk capacitors for the entire VRM. Um, so yeah, and I'm not really a big fan of that. Now then, finally, on the back of the card, if you want to use the Elmore EVC2 dongle to control the voltage on this card, which I'd say is the best way to control the voltage on these cards, you literally just have to solder a header over here, because these are connected. Like, this is the I2C interface connector. So yeah, you solder over here, and you get control, and you get a connection directly to this and this. You could use other dongles to control these two chips, but the EVC2 is probably the most convenient way of taking control of the VRM on a 6900 or 6950 XT. And yeah, this is the easiest place to hook that up, at least. Like, arguably you could connect it directly to the controllers, but like, I don't know why you'd want to be connecting things to these tiny little pins when you can connect things over here. So yeah, though, do be careful. You can accidentally, like, if you are connecting something to this, don't bend the header too much once it's attached to the PCB, because it'll potentially rip the pads out of the card. They're not exactly like those pads aren't super like tied into the car, like into the PCB of the card. So they're not designed to take a lot of physical stress, is what I'm trying to say. So yeah, anyway, that's the Nitro Plus Pure 6950 XT PCB, and just a very solid card for, well, everything really. Right, you've got your, I mean, I'm not, the underfill's neat. I just think that's a nice addition, especially if it does help with the reliability of the card, in, typical case mounting orientations. And then you have the fuses, which if the warranty expires, you've got a much better chance of getting the card repaired. And then of course it also has dual BIOS, power delivery, solid, like, yeah. It's not the most overkill of 6950 XT PCBs out there, but at the same time, it's just got a lot of, like, it's just nice. So if you're considering this card, I'd say the PCB is not a concern. Yeah, like, if you're trying to choose a 6950 XT and this one is at a good price, and there's another one that you're, like, the PCB on this is very capable. I have really nothing to complain about, well, other than the input filtering. But that's a complaint that I have for almost every 6950 XT, is just like, where's the input filtering? Why is there so little? Yeah, so that aside, just a very, very solid 6950 XT PCB. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description. There's also the AHOC Teespring store, which where you can get, like, shirts, hoodies, posters, the usual YouTuber merch. I also have a Bandcamp where I post music It's debatable whether or not it is music, but hey, there's a link to that down in the description if you want to check it out. You can support me that way. And yeah, so all of those links. So yeah, I have a Patreon, Teespring, Bandcamp. If you want to support me through any of those, it would be much appreciated. There's links to them down in the description. That's it for the video. Thanks for watching, and goodbye.